I've got this problem here. I've got $5,000. I'm going to invest it for 4 years at 7% compound interest. What will it amount to at the end of this period? Okay? If I'm thinking about this in terms of my sequences series, I'm looking for after 4 years. What term number is that going to be? What term number are we going to find? Not 4, but I'm going to use 5. So there's my first one. So after 1 year, I'll be there. After 2 years, I'll be here. After 3 years, I'll be there. After 4 years, I'll be there. So actually, what I'm looking for is I'm looking for the 5th term, is what I'm doing. Now, is this going to be an arithmetic or a geometric sequence? It's geometric. I'm multiplying. Okay? What am I multiplying by? 7%. Now be careful. 7% is part of it. All right? But what is my R value? Well, I want to keep all of my 5,000. So I'm going to go 1 plus, I'm going to change that to a decimal, 0.07. So that is my R value. If you'd like and you want to say R equals 1.07, that's perfectly fine as well. So that's my R, that's my common ratio. All right. If you were to multiply by 0.07, your money's going to get really little really fast and you're going to be very disappointed in what you have in the bank. All right. So 1 plus 0.07. So what I'm going to do here is 5,000. Actually, let me do this. UN equals U1 times R to the n minus 1. That's the formula that I'm going to use. Am I summing all the money up as I'm going? Am I taking after 1 year and adding after 2 years and adding after? No, I'm finding what it is after 5 years, okay? I'm finding the term number is what I'm finding. So this is not a sum. I don't get to figure out what I have after this one and this one and add them together. It's a constant adding to it as I'm going, right? So there's the one that I'm going to use. My U1 is what? 5,000. We have our common ratio. It is 1.07. What term number am I looking for? The 5th term. Now this is what's confusing, because if we were just doing this exponentially, which we're going to be doing this in the next unit, if we were doing this exponentially, we have 4 years and we just put 4 there, correct? But when we're thinking of this in terms of sequences series, that's actually term number 5 that we're finding. All right, so 5 minus 1 is the 4. So I'm going to take that and go put that in my calculator. So if I were to do that, I'm going to go clear this on new. No, so I'm going to put add a calculator. I'm going to go 5,000. And I'm going to go parentheses. I'm going to go 1.07. And I'm going to raise that to the, you can go 5 minus 1, or you can put 4. I don't care. So the number that I would have at the end of 4 years, I would have 6,553 and 98 cents. Okay? 6,553 and 98 cents is what goes there. Everybody okay on that one? So there's a little blending of some concepts here. It's exponential equations that we'll talk about soon, but we can also solve this using our sequences series. Okay? All right, let's try another one. Give you a chance to set this one up, read it, and see if you can set it up. Then we'll discuss it. Reads very similar, doesn't it? What information have they given me?
How much you start with, and then how long you're doing it, and then your compound rate.
What's this 10,000?
The last.
It's the last term, yeah. And so in 4 years, this is what I'm gonna have. So that's my last term, but this is the term that I don't have, right? I don't have U1. Do you know your common ratio? 1.085%. Make sure you move that decimal twice, right? So that's my common ratio. I'm using the same formula. I'm going to use UN equals U1 times R to the n minus 1. Okay? So fill in what we have. What do we know? What can we fill into the equation? R, 1.085. What else? UN. What is UN?
10,000.
The 10,000 is my UN. What term number is that actually?
1, right?
Is what?
Is it 1?
The 10,000?
No.
It's the 5th term.
Oh. Never mind.
Okay? And so the 10,000 is my 5th term. I don't know my U1, and I know what term number it is. It's 5, so 5 minus 1. So in this one, I didn't give you the beginning amount. I gave you the end, and we're trying to go find that. Now, how would you solve this for U1? Divide by whatever that is, okay? That's some number. I don't know what that number is, but I'm going to divide by that number. So I'm going to go do that in my calculator. I'm going to divide by that number over here, and I'm going to divide by that same number over here, whatever that number is, okay? I'm not even going to claim to even have close of a clue on that one, all right? I'm just going to use my calculator, all right? I like to do this type of problem in 2 steps. It's me personally. You can do it all in 1 step if you'd like, but I'm going to go 1.085, and I'm going to raise that to the 4th power, or 5 minus 1. So that number that's sitting right by U1 is 1.3858, whatever, okay? I'm going to divide by that. So I'm going to take my 10,000, and I'm dividing by, I'm going to use my up arrow so I can highlight that, so I don't have to retype all that. And then I hit enter, and there's my U1. Okay? So my first term, all right, I have to have $7,215 and probably 75 cents. I'm going to round it up. $7,215.75. If I invest that right now, then in 4 years, it will be the $10,000 that I want. Okay? We had a problem kind of like this in some of our homework a couple days ago where we were having to solve for the U1, and so that's what I would do. I'd find what that is, divide by it, and go get that other number. Okay? Everybody good there? All right, let's try a little bit different application problem. Give you a chance to look at this one, then we'll discuss again. It's not, that's just the top of it. Okay, so that's kind of some of the things we're gonna have to figure out. So it's a nice day outside. You get told to go outside. We need to count the wood pile so that we know if we have enough wood for the winter to burn fireplace or whatever. You can go out there and count it all right? But it's stacked really nice and neatly. So this is the top 2 rows right here. The bottom row has 51 logs in it, okay? And so what is the goal in this problem?
To figure out how many.
To find the sum, to figure out all of them, all right? And so, so if I'm doing the sum, by the way, anybody count the top row?
It's got 50.
Got 15. All right, so if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. There we go. All right. And the second row has what? 16. If you match them up like this, then I've got one extra one, which that tells me my common difference is 1. Okay? And so if I'm going to do this right here, the first sum that I'm thinking about is n over 2 u1 plus un. Okay? So this is arithmetic. I'm adding one each time to it, so I know it's arithmetic. That's the easy arithmetic problem.
How do you know what formula to use and when?
I know I'm looking for the total amount here. I'm looking for the sum. So I'm going to use the one with the S on it, the sum. Okay?
Are all the formulas on our?
They are. Page 2. All right? They're all the top 5 things on page 2 on your form sheet. Okay? And so I'm doing that. Now, what information do you know in this one?
UN.
You know UN, it is what?
51.
51. That's the bottom row. You know the top row?
Yeah.
Yeah, we counted it, right? It's 15. So this is 15 plus 51. What's the thing that I don't know though? I don't know how many rows there are, correct? So then you go find this. If they were just told me the number of rows, which if I was actually there in person, could I count the rows?
Yes.
I could count the rows and this would be a lot easier problem. But for right now, I can't picture it. And so I need to go find that row. So I'm going to use the other arithmetic formula. I'm going to use UN equals U1 plus D times N minus 1. Okay? So what's my U1? 15. What's my common difference? 1. And I want to know the very last row. I want to know what row number that is. That's 51 that goes there. But if I solve for n, it's going to tell me what row number I'm on. Okay? Yes, sir?
UN just stand for
The last term.
Okay.
Yeah. Or whichever term I'm looking for. I want to know the last one because if I'm counting from the top, that's the first row, the second row, third row. I'm counting downward. I need to know what row this is. Okay? So I'm going to subtract 15. Subtract 15. I believe that's 36. I like this. 1 times n minus 1 is just n minus 1 because 1 times anything is whatever it is. I'm going to add 1 to it. So n equals 37. That's what I was missing right there. So I now have everything I need to plug into my formula. I'm not going to worry about doing that by hand. I'm going to plug that into my calculator. I'm going to go 37 divided by 2. I'm going to multiply it by 15 plus 51. This is 66.
And this is the number of logs?
This is the total number of logs.
1,221.
That is correct. It's a lot of firewood, right? I don't know that you're going to need that in Texas or where we live, probably. All right, bless you. Unless we have like the little snow apocalypse like we had several years ago. All right. I wish I would have had a little bit more wood at that point in time, but there we go. Good? Questions on that one? It's a multi-step thing. You got to be able to handle that as we go. All right. Want to do one more kind of word problem like this, then I need to show you the recursive series. All right. All right, I'm gonna give you a chance to read this. Then we're gonna pull out some of the key words and go from there. What are we looking for? First term common ratio, so there's 2 variables, correct? There's 2 things I'm looking for, all right? What's another key word that I'm looking for that's going to be helpful for setting this up?
The convergent geometric.
Convergent geometric. Another way of saying that is the infinite sum, all right? Convergent geometric is infinite sum. So I'm using this formula right here, all right? So when it says convergent sum or geometric, infinite sum, I'm talking about that one. So what is the answer to this problem right here? 27. So there's that first equation. That's kind of an easier equation. I like that equation. It's pretty easy, but I do have 2 variables missing. So I'm kind of stuck. All right. I'm going to go handle the other part. Where's this 19 coming from?
The first 3
The
terms.
first 3 terms of the geometric. So that's the sum of the first 3 terms. If I go look at my formula sheet, the sum of a geometric is U1 over 1 minus R to the n over 1 minus R. I've been doing this for a while. I have those memorized, but you may not. Go, you look at your formula page, pull this off the formula page. What can I plug into this formula that I know right now?
No.
The sum is 19, okay? I don't know U1, okay? I do know the n. So there's what I know so far. Okay. Now, essentially what I have here is I have a system of equations. I've got 2 equations, 2 variables. So we could eliminate, we could substitute, you might graph. If you change the variables, make them x and y's, that would work. This is what I'm going to do. On the bottom here, I have a 1 minus r. On the top, I have a u1. So I have a u1 over 1 minus r. Is that important? That's the same as this over here, correct? u1 over 1 minus r, that's the same thing, that's equal to 27. So what I can do here is I can say 19 equals 27, 1 minus r cubed. So I substituted, I took the u1 over 1 minus r out, I put what it's equal to 27 here. Everybody okay with that? If not, some other people have done this one. If I multiply by 1 minus r there, then I can go 27 and 1 minus r here is equal to u1. And if you'd rather do it that way, then take the u1 out and put that at the spot there. It's another substitution, okay? And you get the same result.
What happens with the 1 minus R3, like?
Here, it's still
Why did you just like?
still in my problem.
Do that then?
Still my, well, here's the thing. on a fraction, that fraction right there, this is like u1 over 1 and 1 minus r cubed over 1 minus r. Okay? If I had just a simple fraction, if I had 2/3 times 4/5, okay? Is it the same thing as that? Same thing, right? I just rearranged it. So basically what I did is I rearranged this. I moved this to be over here, and I moved that to be 1 right there. Because u1 over 1 minus r is 27. So I substituted for that piece. Sorry, I erased that. Substituted for that piece, and it left me that. So I substituted and made 27. Now I have that left. Make sense? Okay. All right. That's the hardest part of this whole problem is there. Now we got to go solve. What would be your next piece? What would you do?
Divide by 27.
I'd probably divide by 27. I think that's the most efficient way. Divide by 27, divide by 27. Some of you going, I don't like the way that looks. That's fine. Just leave it like that for now. Okay? So divide by that. Now what?
Minus 1.
Minus 1. Now I'm going to do a little something different here. I'm on minus 1, but on the other side I'm not going to put minus 1. I'm going to put minus, since it's a 27, I'm going to put minus 27 over 27. Is that minus 1?
Yes.
It's the same thing, right? So minus 1, but now what I can do is, now I can put that together, correct? What's negative 27 plus 19? 8. Negative 8, that's correct. So I have negative 8 over 27 equals negative r cubed. I can say that's plus. All right? It's negative on both sides, it's plus. And then I'm going to take the cube root. What's the cube root of 8? 2. 2 times 2 times 2 is 8. All right? Cube root of 27? 3. 3 times 3 is 9 times another 3 is 27. So the answer here is r equals 2/3. Do you feel like we're on the right track?
Yes.
Why?
Because now we have another variable.
We do have one variable, so that's good. How do I know that I think I'm pretty much on the right track on that one. What's that mean? What has to happen with all convergent series? R has to be less than 1. Am I less than 1? So that's what kind of gave me a clue that I think I'm on the right track. That makes sense? All right, all those pieces are going together. Now, I need to take the R and plug it back in. I'm going to take the R and plug it back into here, or I can take the R and plug it back in over here. I think I'm going here. Okay? It just looks easier. So if I were to do that, then 27, I'm going to put it at the bottom just so I have a little bit more room. So 27 equals U1 over 1 minus 2/3. What's 1 minus 2/3? 1/3. U1 over 1/3. How do you get rid of 1/3?
Times 3 divided by.
Multiply by 1/3. Multiply by 1/3.
9.
1/3 of 27 is 9. So the first variable was harder to find. Yes. Second variable was a little bit easier because we could plug back in. All right, that's all systems. Anytime you have two variables missing, all right. Questions on that one? I wanted you to see that one and you hear the terminology in that because that's a little tricky one to set up. All right. Want to do couple other little problems with you real quick. Last couple examples we're going to talk about are recursive series. All right, so we're going to talk about recursive. All right. I can't spell, huh? Let me try that again. There we go. Recursive series. That's a 5. U1 equals 5. UN equals 3. UN minus 1 minus 1. All right? And I want to find the first 5 terms. Okay? I want to find the first 5 terms. Well, what's the first term? 5. Anytime that you're doing a recursive series, they're going to tell you where to start. They're going to give you the first term. First term is 5. So 1, 2, 3, 4, 5. I'm finding the first 5 terms, and the first term is 5. Okay? To find the next term, to find UN. So we're going to say this is UN right here. To find UN, what does it say? 3 times what? What's UN minus 1? The previous term. That's what that means. To find UN, I'm going to do 3 times the previous term minus 1. So what's the previous term? 5. So I'm going to go 3 times 5, which is 15, minus 1 is 14. That's the second term. Okay? How do you find the third term?
Wait, what? 3 times 14 minus 1.
I got to use the one before it. So 3 times 14 is 42. Minus 1 is 41.
I understand.
Okay? How do you find the fourth term?
3 times 41.
3 times 41.
Minus 1.
Just had to do that one, right? 123, 122, I believe. Is that right?
Yeah.
Okay? And then
My apologies.
to find that one, then I'm going to multiply that one by 3, which is 366 minus 1 was 365.
Yep.
Yeah.
Okay, so I know one.
Okay. Now, the only bad thing about that one, that was pretty easy, right? You just kind of keep plugging back into the formula. Only bad thing is if I'm going to go to the 50th term, guess what I have to do? That 50 times, because they're all tied together. That makes sense? You can't jump to the end like you can on the others. Make sense? So you just have to keep plugging them in and going as you go. Question? Yeah. So I'm probably not gonna ask you to find the 20th term. I'm gonna ask you to find the first 4 or 5 of those as we go. Alright, let's try another one real quick. Alright? So if I say U1 equals 4, UN equals -2, Alright, find me the first 5 terms for that one.
You said the first how many?
5.
Wait, Coach Rice, I'm kinda confused.
Okay.
Okay, because like for the first one,
Mhm.
UN minus 1, wouldn't that be 4? So then you're doing like 3 times 4.
The first one
like
is
the-
4.
You're talking about the problem we're on right now?
Well, like, I'm talking about like the other one too, just like,
So what's my first term?
it's 4.
4. So 4 goes there.
Yeah.
Okay? Now to get this one, alright, I'm using the one before it. So I'm gonna put the 4 in.
Yeah.
So that's -8 plus 3 is
That's what I'm saying, is like,
-5.
that's what I'm saying, it's like, it would be 4 minus 1. I got it. Like,
Where you get 4 minus 1?
4 minus 1 would be.
No. N minus 1 is just a notation. N minus 1 means use the one before. That's what N minus 1 means. So if I'm looking for N minus 1 means use the one before. So each of those are gonna be UNs, alright? So I'm not plugging in for this. This is just a variable. Okay? That means I'm using the previous term. U to the N minus 1 means that's the term before. Okay? So that's not actually part of the plug-in part.
Okay, I'm so
Okay?
confused about that.
That better?
Oh, yeah.
Alright? So now, take the -5, plug it in. So I get 10 plus 3 is 13. Okay? Take the 13, plug it in. -26 plus 3 is -23. And then that would be 46 plus 3 is 49. Okay? Everybody alright with that? Now, if you had to, if I gave you 5, 10, 15, 20, if I gave you this sequence, and I asked you to write a recursive sequence for that, alright? If I asked you to write a recursive sequence, the first thing you would tell me is that the first term is 5, okay? Then you would tell me, how am I getting from one to the next? I'm adding 5. So it's a U to the N minus 1. So take the previous term and add 5 to it. And that would be my recursive series. Okay? All right. You have 2 pages of homework tonight, but you can scratch off 43, which means you have 1 page of homework tonight. You have page 10.
Wait, Coach, come look at my homework.
What's today's date, the 15th?
Yeah. Just
How much time until Pop?
not